Software-defined networking is a centralized, dynamic, and programmable network management technology that enables flexible traffic control and scalability. While SDN facilitates network administration through a centralized view of the underlying physical topology, tampering with this topology view can result in catastrophic damage to network management and security. In contrast to the existing localized topology poisoning attacks initiated from a data plane, a control plane topology poisoning can be a sophisticated globalized attack. Let's go over the link discover process on most SDN platforms. Suppose a controller connecting with OpenFlow switches A and B. The controller first sends switch A packet out message encapsulating an LLDP packet and instructs switch A to send it by port 2. Switch B receives the LLDP packet by port 1. Because of the table miss flow entries on switch B, the LLDP packet is fed back to the controller by being encapsulated in a packet in message. Therefore, the controller learns a link from switch A port 2 to switch B port 1 by parsing the packet in message header and the LLDP payload. However, if there is a malicious SDN application on the controller, it can manipulate discovered links precisely. In this 3-node topology, if the malicious SDN application learns network topology and instructs the controller to set up a flow entry on C making the LLDP packet sent from switch A port 2 forward to its port 2 instead of sending it to the controller by the packet in message, the LLDP packet will be sent back to the controller by switch B not switch C, which leads a fabricated link from switch A port 2 to switch B port 1 to be discovered. We target manipulating links precisely and creating a realistic topology by maintaining the same degree sequence between the real and deceptive topologies. We call the flow entry influencing the result of link discovery a poisonous flow entry. We omit details of it because the poisonous flow entry design is not a trivial problem. Our poisonous flow entries are also designed to be stealthy without matching on LLDP Ethernet type, which hides them in millions of flow entries on a switch of practical networks. We are going to demonstrate our attack with this simple example on open source controllers connecting with Mininet. On the left-hand side, it is the real topology that will be customized on Mininet. On the right-hand side, it is the fabricated topology we strive for. Graphically, those two topologies are isomorphic. But they are different topologies in the network domain because of different link connections. In detail, the goal is to achieve links from switch A port 1 to switch C port 2, from switch A port 2 to switch B port 1, and from switch D port 1 to switch C port 1. Okay. Let's watch the experiment demo next. We built our testbed on the Cybervan platform. We have 6 virtual machines connecting with each other and 5 of them are open source controllers. The other one is the Mininet. In this demo, we will establish OpenFlow session between ONOS controller and the Mininet. The IP address of ONOS is 10.0.3.3. The IP address of Mininet is 10.0.3.2. On the right-hand side, we have the ONOS virtual machine booted up. On the left-hand side, we have the Mininet terminals. The ONOS version is 2.2.0. Let me start the ONOS. Okay, started. Let me open the graphic user interface of ONOS. Next, let's start and connect the Mininet with ONOS. The controller's IP address is 10.0.3.3, which is the ONOS machine IP address. We can see the connection is established from the ONOS graphic user interface. As we mentioned, because it is hard to tell the different graphic topology for this example, let's switch to the link information page. Before we initiate the attack, let me show you the flow entries on the mininet. We can see that the ONOS uses Ethernet type as the match to handle the link discovery packet. The one with 0x88cc match is for LLDP packet. The other one with 0x8942 match is for BDDP packet. Now let's attack. You can see that the link information has changed. There are 4 more links being discovered. Hold on to see which links are going to be expired. Alright, it has been settled down. This is exactly the deceptive topology we designed. At last, let's check out the flow entries to uncover the mystery. The elaboratively designed poisonous flow entries are set up on the switches. They tamper with the LLDP and BDDP packet forwarding path, which cause the topology information to be poisoned. That's all. Thank you.